Hello and welcome back to BlessedMath. Remember you can visit us at blessedmath.com for all tutoring lessons and for tutoring resources. We're your Atlanta-based tutoring resource. So today we're going to be going over systems of equations and inequalities. This is part 1 of an 8-part series. Our first lesson in systems of equations and inequalities. This assumes that you already know how to solve equations. So the main things we're going to be going over is how to deal with systems involving more than one linear equation. Example 1, tell whether the point -2, -1 is the solution of the system. The system of equations being the two lines, 2y minus 3x equals 4 and x plus 2y equal -4. Remember, the -2, -1 represents the x and the y point on the coordinate plane. So does the first line, 2y minus 3x equal 4, pass through the point -2, -1? And does the second line, x plus 2y equal -4, pass through the point -2, -1? Well, what we're going to do is substitute the -2 for x and the -1 in for y in both equations. If the equations maintain their equality from the left side of the equation to the right side of the equation, then it is a solution for that individual equation. If they maintain their equality for both equations, then it's a solution for the system of equations. So in the first problem, we end up with 2 times -1 minus 3 times -2 on the left side and 4 on the right side. 2 times -1 being -2 and 3 times -2 being -6. But you notice we have a subtraction sign in front of the 3, so we can take it as -3 times -2 being a positive 6. So we can simplify it to -2 plus 6. Is that equal to 4? Yes, it is. So 4 equals 4 is true. So the point -2, -1 solves the first equation. But does it solve the second? Substituting -2 for x and -1 for y, we get -2 plus 2 times -1. Is that equal to -4? Well, 2 times -1, that will be a -2. So we have -2 minus 2, or -2 plus -2, is that equal to -4? Yes, -2 minus 2 is -4, and -4 equals to -4 on the right side, so we can say for this system, the point -2, -1 is a solution. Same thing, we're going to plug in the point 2, 3 into the two equations in this system. The first line being x plus y is equal to 5, and the second being x minus y is equal to 1. Substituting the 2 for x and the 3 for y, we get 2 plus 3, is that equal to 5? The answer to that is yes. 2 plus 3 is 5. 5 is equal to 5, so this is true. So it solves the first equation. Let's see if it solves the second one. 2 minus 3, is that equal to 1? Well, 2 minus 3 is -1, and -1 is not equal to 1, so it does not solve the second equation. So we can say the point 2, 3 is not the solution of this system of equations. Moving on to part 2 of lesson 1, let's see if we can solve the systems visually by graphing the lines. All right, remember we have a coordinate plane. We have our x going across the horizontal and our y going across the vertical axis. And we have two lines that lay on this plane. Y equal x plus 2 and y is equal to 2x plus 4. Remember when graphing lines to look for the number in front of your x, and that will be your slope in the way that these equations are laid out, y equal mx plus b in the slope-intercept form. And the remaining constant will be your y-intercept. So for the first line, we're going to graph y is equal to x plus 2. Then we're going to graph y is equal to 2x plus 4. Now, the point that solves both of them will be the point on this plane that both lines intersect. So let's see if we can find an intersection between these two lines. We're graphing y is equal to x plus 2. You'll notice the slope is 1. And the y-intercept, it crosses the y vertical axis at the point of 2. We're going to graph the next line of y equals 2x plus 4. You'll notice the slope is twice that of the first, being 2, and the y-intercept crossing the y vertical coordinate at the point of 4. But we do see a point. They both cross the same point on this graph. Actually, only one point do they intersect? And that point is -2, 0. So because the lines intersect at the point -2, 0, meaning x is -2 and y is 0, we can say the point -2, 0 is the solution of this system of equations. Example 2. We have y equal 3x plus 4 and y is equal to 3x minus 5. Some of you are already noticing that the slope for both of these are 3. So they have the exact same slope. Let's see what happens when we have two lines with the exact same slope. First, let's graph y is equal to 3x plus 4, slope of 3, y-intercept of 4. Then let's graph y is equal to 3x minus 5, a slope of 3 with a y-intercept of -5. You'll see the 3 means we have a steep slope. We're raising 3 and we're moving over only 1. So it's a nice steep slope and we're crossing the y-axis at 4. On our second line, it's that same steepness, that same slope of 3, but this time the y-intercept is -5. Well, if these go on into infinitum, up and down in this graph, you'll see that they never cross. And that's because they never have a common point on this graph. Some of you know the name of that. That is called parallel lines. And any two parallel lines do not have a solution. So the lines do not intersect and the system does not have a solution. So in this case, we say that there are no solutions to this system of equations. All right, you guys. Join us next time when we'll be going over some other techniques for solving systems of equations. Remember that you can check out our website at www.blessedmath.com. And you can go there also for all of your Atlanta-based tutoring needs and resources.